In this video, we're going to take a look at some of the applications of the normal distribution. The normal distribution shows up a lot in nature, or at least close approximations to the normal distribution show up a lot in nature. And I want to work through one example really thoroughly and show how you can compute probabilities related to a normal distribution using both the calculator, Excel, and a set of tables that I will provide for you as well. So I'm just going to look at the following example. It turns out that IQ scores follow a normal distribution. So IQ scores follow a normal distribution with scores having a mean of 100. So 100 is the average IQ score, and a standard deviation of 15. So with this information in mind, I want to ask a couple of questions. So the first question I want to ask is, what is the probability of finding somebody that has an IQ above 140? So if you were to randomly pick somebody out of the crowd, what's the probability that their IQ is above 140? So what is the probability of a randomly selected individual having an IQ above 140? Okay, so I want to answer this question using all of the strategies that we just talked about. I want to do a table, I want to use the graphing calculator, and I want to use Excel and see if we can figure this out. But the first thing I want to do in all of these cases is draw a picture. Pictures make these problems a lot easier. So even if the problem doesn't request that you draw a picture, I'm ultimately going to request you draw a picture on the exam, so might as well get used to it. And the picture almost always helps sort of keep things straight and figure out the details of what's going on here. So I'm going to start with my picture of my normal distribution. And again, X, my random variable here, is going to be IQ scores. It's IQ scores that we just said are are normally distributed. And we said the average IQ score right here in the middle is 100. And a standard deviation, which as we saw in the last video looks about this distance, that should be 15. So the standard deviation is sigma equals 15. And so if we do this, we can figure out what the IQ scores are. So one standard deviation above average would put us right here at an IQ score of 115. And if we went 2 standard deviations out above average, we'd be at an IQ score of 130. And by the time we were 3 standard deviations, we'd be way out here at 145. And if we did the same thing in the other direction, so let me slice this up the same way that we did before. This point right here, 1 standard deviation below average, this IQ score would be 15 less than 100, which is 85. And then 15 less than that would be 70, and then 15 less than that would be down here at 55. So these are sort of the way that the IQ scores are distributed. A lot of people have IQ scores here near the average, around 100, maybe a little below, a little above. And it's very rare, it looks like, to find people with very low IQ scores below, much below 55, much above 145. Those seem rare because there's very little area over here. And remember, area corresponds to probability. So I want to standardize this curve by converting everything to z-scores. So if instead I was interested in z-scores instead of the IQ scores, what is the z-score right here at the average? remember at the average, the z-score is 0. We are 0 standard deviations above or below average because we're right at the average. 1 standard deviation above has a z-score of 1. 2 standard deviations above has a z-score of 2. 3 standard deviations above is a z-score of 3, and so on. Same thing in the other direction. -1 is 1 below average. -2 is 2 below. -3 is 3 below average. And so now that we have this picture drawn, I want to look back to the original question. It's asking us, what is the probability that a randomly selected person has an IQ above 140? So where does 140 fall over here? Well, here's 130, here's 145. It's going to be between these two numbers, and it's a little bit closer to the 145 than the 130. So I would say it's right about here-ish. This right here is the value that we're interested in. So here is the IQ score of 140, and we want to figure out what is the corresponding z-score for that value, because that will be useful to us. The z-score, as you'll recall, is x minus mu divided by sigma. So in this case, the x value of interest is 140. We subtract off the mean, which is 100, and we divide by the standard deviation, which is 15. And so if we do that just on any calculator, I'll pop out the graphing calculator here, and we can just do it on here. If I do that, I will get, let me do my parentheses, 140 minus 100, which is going to be 40. And then we divide that by 15, and we get about 2 2/3, so 2.6 repeating. I will approximate that to 2 decimals as 2.67. That's going to be the z-score that we're interested in. And we're interested in this area over here, which doesn't look like it's going to be very big. This is the probability that x, the IQ score, is greater than 140. And it's going to be the same as the probability that the z-score is greater than 2.67. I want to just point out as I'm doing this, whether I use a greater than symbol here or a greater than or equal to symbol doesn't make a difference, because if you include 140 exactly, remember that the probability that x is exactly equal to a given value is always 0. So it's not going to change the overall probability. Whether I use the greater than symbol or the greater than or equal to symbol, I'm going to get the same result. So just keep that in mind as you do these. And it's because this case right at the edge, right here, the probability of that specific outcome is 0. So I'm going to just keep them off, but you're welcome to keep them written on there as well. But this is what we're trying to find. We want to find this probability which corresponds to this little tiny area. It looks like it's going to be a small number. So let's do this a couple of ways. Approach 1. I want to do this on using the table, because I think the table is going to be sort of the most insightful approach, and it's something that we can all use regardless of whether you're used to using the calculator or you're used to using Excel. The table works regardless of either of those technologies. So you're welcome to use those technologies. We'll show you those as approaches 2 and 3, but for now I want to use the table. I've already got the table that we need right over here. So the table is 2 pages, and it looks like this. And again, I've provided it for you so you can download it from the class website, and I will provide this also on upcoming exams and so on. So this is table A2 in the appendix of the textbook. If I refer to this as either a Z table or table A2, this is the one I'm talking about. And it is a table for the cumulative normal distribution. And if you look at the picture, it has a picture that's similar to the one that I've drawn. It's got a normal distribution curve, and it's standardized, where you'll notice the average, the center of this, is at 0, and it has this other mark here that says Z, corresponding to sort of the edge of the area that we're interested in. And notice the area starts at the left and goes up to a given z-score. So this is using the standardized normal distribution. It's using z-scores, and that's why it was important for us to convert. It's not an IQ score table, it's a z-score table or a z-table, and that's why we need this value. What this table will do, if I can get them both on the screen here at once, what this table will do is if I pick a given z-score, and I can pick that z-score by going down along to these various rows here, and then over along these various columns to get a z-score to 2 decimals. I'll demonstrate that in just a minute. But these values in here are all of the areas / probabilities that we're interested in. So all these values in here are areas or probabilities, and along the edge we have z-scores. So in this case, I'm interested in looking up a z-score of 2.67. But I want to keep in mind when I look up that z-score, it's going to give me the area to the left of that z-score. Because I'm interested in the area over here of the area to the right of a given z-score, I'm going to need to use the rule of complements. So we'll be using that along with this table in just a moment. Okay, so back to the table, and we'll just keep in mind 2.67, that's the number that I'm interested in. This table is 2 pages. The first page, you'll notice, involves all negative z-scores. The picture shows the area being to the left of center, which means the z-score is below average, meaning it's negative. So if I wanted to look up one of these areas, I would just pick the number. If I wanted the number negative 1.58, so if I was interested in z equals negative 1.58 for some reason, I would go down and I would find z equals negative 1.5. This gives me the first decimal of accuracy, but to get the second decimal, I need to use this. I need the 8, so I need this one here. This gives me my, sorry about that, this gives me my second decimal. And I would go down and find the entry in the table that corresponds to that. So it's going to be that number right there. If I picked z equals negative 1.58, the area associated with that z-score, the area to the left of that z-score, so negative 1.58 would be about 1.5 standard deviations below average, so somewhere over here. That area to the left of this would be 0.0571, and that's how we're going to use this table. So again, why negative 1.58? No reason, I just made that up off the top of my head. The one that we care about is 2.67. To get to that value, I need to go to the side of the second page of the table, which is going to have all of the positive z-scores. So if I go to the second page, you'll notice all of the z-scores are positive. And so here's the value we actually want. We want z equals 2.67. And so to find the area associated with z equals 2.67, what I'll do is I'll come down here and find 2.6. Then I'll go up to the top and find 0.07. And I will find the intersection of these values. So I come down on the table, down to here, over to here, and you'll see there's the value that we're looking for. It is, zooming in for those of you that can't see this, come on this page. Just move this real quickly, sorry. It stops flying around here. Supposed to be able to lock this in place, but it clearly didn't work. Anyways, the value is 0.9962. That is the area to the left of z equals 2.67. So going back to our problem, we look up z equals 2.67 to find that the area to the left is 0.9962. That's the number that we just found on that table right there. But I don't want the area to the left, right? That's the area of the unshaded region over here. If I want the area of the shaded region, I'm going to have to use the rule of complements. If we want the area to the right, we need to use the rule of complements. So basically what we were able to find was the probability that somebody had an IQ less than 140. If we want the probability that somebody has an IQ greater than 140, we use our rule of complements. So the probability, again, that x is greater than 140, which we said is the same as the probability that the z-score is greater than 2.67. Well, that is equal to 1 minus the probability that z is less than 2.67, or less than or equal to. This is the area to the left that we just found. So I do 1 minus the area to the left that we just found, 0.9962, and what we're left with is 0.0038. That is the answer. That is the probability that we were looking for. So what is the probability that somebody has an IQ above 140? It's pretty slim, 0.0038. So less than 0.5% of people have IQs in this range. This is pretty high up there. So this is the probability that we found. 0.0038 is the area of this tiny little tail region that we just found. Okay, so this is the answer. Using the table, we look up the value, and all we need to keep in mind is that the table only is going to give you areas to the left of a given z-score. So if you want an area to the right, you need to use the rule of complements. I'll also do an example later on where we need to find an area between two different z-scores. We can see how that looks. So let's try the same problem with a second approach. Let's do approach 2 on the calculator. So on the calculator, how do we do this problem? Let me bring the calculator back up here, and let me bring this table over to the side. That should be good. And I want to see how we can do this same problem. So let me turn on our calculator, and I want to use the distributions again. So the same way that we found the binomial distribution, I want to find the normal distribution. So it's here under the DISTR button. So second vars to get into the list of distributions. And the top two you'll notice are normal PDF and normal CDF. Normal PDF is not something we are ever going to use. It returns the height of the curve at a given point, and we don't ever want that. We always want the area. So we're only going to ever use this second option, normal CDF. So again, we're doing second vars, and that gets us to our list of distributions. And then we select option 2, which is normal CDF. So let me select that second option, normal CDF, and it's going to come up with possibly various things here specified. What it's going to have is the lower bound, the upper bound, the mean, and the standard deviation of the distribution that we're interested in. And so we can do this with the values that we just found, the z-score, where the mean is 0 and the standard deviation is 1, right? This is, if you use 0 and 1 for your mean and standard deviation, that means you're dealing with a standardized normal distribution, and you want to use the z-score values that you found when you're specifying the lower and upper bounds of the region that you care about. But you don't have to use 0 and 1. You can actually use the ones related to the problem. So the easiest way to do this one is what we're going to actually select is instead, I want, looking at the region that we're interested in, I want my lower bound to start here at the left side of this little shaded region, and I want the upper bound to go basically off to infinity. Let me scroll down here and specify, I guess it won't let me until I do these. So I'm going to change these two values to correspond to the actual IQ scores. The average value is 100. The standard deviation was 15. These two values were given in the problem. And I'm going to give now the bounds of the shaded region here. The lower bound of that shaded region, the left side of that little shaded region, is at 140. So I'm going to put 140 in there and hit enter. For the upper bound, I want it to go to infinity. You have a couple of options here. You can just type in a really big number, like a bunch of 9s, and that will work. Or I can actually type in a number that's basically the largest number the calculator can hold. You'll notice the number that I just erased up here looked kind of weird. It was like a -1 and it had an E in it with some letters. I want to type in the equivalent thing. If I do 1 and then do the second option of the comma button, so second comma, it looks like these two little E's here. It's going to do a little E down here, and it basically is putting us into engineering or exponent notation. And I'm going to put 99 here. What this is doing is basically giving us a 1 followed by 99 zeros. It's essentially the biggest number the calculator can handle. So this is, for all intents and purposes, infinity. As far as the calculator is concerned, this is infinity. So the idea is that technically this distribution continues on forever in that direction and forever in that direction. It's just in practice, right? There's not a lot of people with IQ scores above 145 anyway, so it doesn't really matter. We don't need to go all the way up to this number. You could just put in a big number here, put in 1,000, 10,000, put in all those 9s like I did a minute ago, and it would give us the same result. But this is the safest way to do it. 1 little e 99, and that little e, again, is the second option of the comma button. So I'm going to do 140 for my lower bound, 1 little e 99, and again, this little e here is the second option of the comma button. So second comma gives you that. This is our upper, or sorry, I'm writing them in the wrong order. This is our lower bound first, then our upper bound. So if you have an older calculator that doesn't give you this menu option, you enter your lower bound, then your upper bound, then the mean, which is 100, and then the standard deviation, which is going to be 15. So here's the value of mu, and then the value of sigma. And you enter them in that order. So let me go down and finish doing that here. I've got that. 100 is the mean, 15 is the standard deviation. And if I now click paste and hit enter, it will spit out the exact probability that we're looking for. And sure enough, this is spitting out about 0.00383042551. It's the same answer. It's just a slightly more precise version of the same answer. So it's giving us the same result as we got doing the table with just a few extra digits of accuracy. So just keep this in mind. If you're working on the homework and it asks you to use the table, make sure you use the table. And if it asks you to use the calculator, use the calculator. Or if you don't have access to the calculator, use Excel, because there are a few occasions where you'll get very slightly different numbers. The answer will differ in this 4th decimal place. And the homework will mark you wrong if you're using the wrong approach, even though you essentially did the problem correctly. A second option, again, for the same problem, is I could have done it with the z-scores instead. So if I go back to normal CDF, instead of using these values, if I instead used all of the normalized versions, so we said the z-score cutoff was 2.67, and that's our lower bound, and our upper bound, I'll just leave it as infinity. But now we use the standardized version, which has an average of 0 and a standard deviation of 1. So now I'm using the z-scores here, right? So the mean is 0, the standard deviation is a distance of 1, and we're using the cutoff z-score of 2.67, which occurred at the same place as an IQ score of 140. So if I do that, I should get a very similar answer. So I'll paste this, hit enter, and again, 0.00379260074, something that would round to the same number that we got over here, 0.0038. Okay, so that is how we can do this problem on the calculator. Let's do the last approach using Excel. For a spreadsheet in general. Let me bring up Excel here, and I can maybe narrow this down because we don't need all the room. So here's an Excel page that's open. If we're doing this in Excel, the function that we want to use is equals, oops, not binomial, equals normal dist. Or in fact, it's just norm dist. So you'll see that if we start typing here, let me get my computer back in laptop mode so I can type. Okay, so if I type in, I start off with my equal sign because I'm doing a formula, and I start typing normal, N-O-R-M. And you'll see the first option here is norm.dist. I can use that one. I could use this one down here that's just norm dist without the dot. Doesn't matter. Either of those will work. So I'm going to select, normal.dist and do my parentheses, and it'll tell me what it expects. It expects us to put in the x value of interest, the mean and the standard deviation, and whether or not we want it to be cumulative, which we will always want it to be cumulative. This is going to work much like the table that we had. It's always going to give us the area from the left tail up to the given x value of interest. So for us, I'm interested in 140 being the x value, the mean was 100, and the standard deviation is 15, and I want it to be true that we're doing cumulative. And what we'll notice, so when I write this, and see if I can write this, hold on just a moment. So coming back down here, norm.dist of the x value of interest, the mean, and the standard deviation, and then we're going to always put true. So for us, it's 140, 100, 15, and then the word true. What it's going to give us is much like the table. It's going to give me the area to the left of the particular x value of interest. So it's going to give me the area to the left of 140. If I want the area to the right, I'm going to need, just like with the table, to use the rule of complements. So what we'll see if I hit enter up here, so coming back to this, I'll hit enter, and it gives me 0.99617, which is very similar to the 0.9962 that the table gave me. It's just an extra digit of accuracy. But this is the area to the left. Use the rule of complements to get the area to the right. So in this case, the probability that x is greater than 140, which is the area to the right, will be 1 minus the norm dist function that we just found. And you could even type this in. I can come back here and type in, modify this as 1 minus the norm dist and hit enter, and it'll give me the answer that we're looking for. So again, 1 minus is our rule of complements that we're using, and it's going to give me 0.00383-ish in this case, which again, looking at all of these, same answer in all the different cases here. So that's what this looks like using Excel, that norm distribution. Okay, let me flip my computer back around here and maximize this again. And let's think about what if we have a different question? So that was one question. What if instead I ask a question like this? What is the probability that a randomly selected person has an IQ between two different scores, maybe an IQ between 110 and 120, let's say. So I want to know the IQ between two values in this case. So let me bullet this as a new question. Let me come up and bullet that one. Oh, I already did. Perfect. So a new question. What's the probability that the IQ falls between these two values? So again, I'm going to just draw a quick sketch. It doesn't have to be perfect, but it'll give me a sense of kind of what we're looking for. So again, here are my IQ scores. Here's the average, which is 100, right? So mu equals 100 is dead center. 110 will be a little above average, so maybe right there-ish. And then 120 will be a little bit more than that. Maybe that's right here-ish. And so now I want this area where, again, these two values are 110 and 120. How do I find the area between two values? Well, this is a little bit tricky. If we're using the calculator, it's going to be easy. But if we're using either the table or Excel, we're going to have to be a little bit clever here. And the way that we're going to do it is as follows. What I'm going to do, so to get the area between these two values, and in general between any two values, what I'm going to do is look at these shapes. So remember, the table and Excel are only going to give me the area to the left of a given value. So if I compare the shapes, I'm going to have one that looks like this. It goes like this, up, and then down a bit. And let's say this is the one where this is 120. And then I have a similar one and let's say this is the 110 version. And if I want the area in between, I can kind of project this one up onto the one above it. So imagine that I kind of shift it up. And what I'm going to get is that this right here, with this value right there being the 110, would be the copy of this area. So I have kind of two different areas here, and I want the leftover. I want the difference between them. So essentially what I'm doing is finding the difference. I want to take the slightly larger area that maybe looks like this, and I want to subtract off the area that looks like just barely going over that. And what I'm left with, again, hypothetically, here's what it would look like to match up to the same size and shape as this one. And when I subtract that off, I'll just be left with that little piece of difference, which is what we want. So I want this piece. I'm going to find the area associated with 120. I'm going to find the area associated with 110 as the IQ score, and I'm going to take the larger area minus the smaller area to get the difference, the area that's the leftover between them. So hopefully that makes some sense. So this is, again, 120 here. Here's the one with 110, and it'll give me the one that goes from 110 to 120. Okay, so in our table, that means I need to convert both of these to z-scores. So what is the z-score of 120? Well, that's going to be 120 minus 100 over 15. The one over here, we're going to get z of 110 minus 100 over 15. And if we plug these into our calculator, let's bring this up. Make it clear. So 120 minus 100. Again, you can do some of these in your head. I know that that's 20 and divide by 15. I'm really just doing 20 over 15, which is about 1.33. And if we do this, it's going to be a difference of 10. So 110 minus 100 is just 10. And 10 over 15 I can do in my head. I know that's going to be 2/3, so about 0.67. But we can just verify that on the calculator if you want. We could do 110, 110 minus 100 divided by 15. And we'll get 0.6 repeating. Sure enough. So there's those two values. I want to find the area associated with them. So what is the area? What is the probability of, or you can just write it in words, I guess. Area to the left of z equals 1.33 is, and we'll do it similarly for here, 0.67 is, and let's write those two areas down. So 1.33 is the first one. So I'll come over here. What is the area associated with 1.33? Well, here's 1.3. So I'm going to start there. Here's my second decimal of accuracy, and I'm looking at that number right there. So 0.9082 is what happens at 1.33. So 0.9082, that is this number, 0.9082. And then I need to look up the area associated with 0.67. So come back over here, 0.67. Here's 0.6. Here's the 0.7 over here. So it's going to be the number sitting right. Let's erase a little bit so we can see. It's the number sitting right there. So there is 0.67. And we get 0.7486. 7486. 7486. And so to find the area in between, oops, that is a terrible little bracket. The area in between is 0.9082, the larger area minus the smaller area. And we can just type that into the calculator real quickly and do, so again, 0.9082 minus 0.7486. And we get about 0.1596. Let me make sure I copied that down correctly. Yes. That is the probability of finding an IQ between 110 and 120. 0.1596-ish. So again, it comes from basically having to find two separate areas and taking their difference to get the leftover piece in between that we're interested in. So hopefully that makes some sense as well. So that's how we can do that on the table. You would do the exact same thing in Excel. So this is really, approach-wise, this is in Excel or using the table. We have to find these values. So again, if I was doing Excel, we could do the same thing. I would just have to go back to laptop mode. So I would just have to type equals norm dist of the first value I'm interested in is the 120 with a mean of 100 and a standard deviation of 15 and true. And this should give us that 0.9082-ish that we got before. And I guess it was, what was it? 0.9088 we're getting here, 0.908. Hopefully I got that right the first time. Did I do this right the first time? Oh yeah, no, we're good. Yeah, okay. So that is the value, no, wrong thing, Excel, there we go. So that is the value that we got associated with the 120. If I want the value associated with the 110, it would be the same thing. So start off with my equal sign, norm dist of 110, 100, 15, and true. And that'll give me the 0.74-ish number. You'll notice these numbers are a bit off compared to the ones we got in the table, and that's because in the table we had to round. We didn't use 1.3 repeating. We cut it off and rounded to 1.33. And we also didn't use 0.6 repeating. We used 0.67. We had to round. So these numbers will be close, but not exactly the same. So here's those two values corresponding to, again, these two values here corresponding to these two values here. They're a little bit off, and again, that's just due to rounding. So this is what I mean. If you use the table when it wants you to do something that's more exact, you'll get the wrong answer. You'll get something really close to the right answer, but it'll be off in the third or fourth decimal place. On an exam, I won't care. Use whichever method you want. I will know that there's rounding errors, and you won't get taken off points if you choose to use the table instead of Excel or vice versa. But again, this is the same idea. We still need to look up those two values. We could type it all into one single formula, so I could write it as equals, normal distribution of the 120, 115 true minus the normal distribution of 110, 115 true. So I could write it all on one line where I actually have it do the subtraction for me and hit enter, and it'll give me the 16-ish% that we found before. We got 0.1596. The more exact answer is 0.161281. Both are very close to 16%. Okay, how do we do this on the calculator? On the calculator, again, I will do second vars to get to my list of distributions. I'll select that second one. And now I just want my lower and upper bounds to be picked. So I want my lower bound to be 110, and I want to go up to 120. Those are the bounds. It's really nice. It does this for us. So I'm just interested in the area from 110 to 120, where the mean is 100 and the standard deviation is 15. I'll hit paste, hit enter, and it will give me the 0.16128 that matches 0.16128, the same answer we got in Excel, but it's a little bit trickier in Excel than on the calculator. So to summarize on the calculator, so this is, again, this is the approach in Excel or using the table. We're going to have to actually take a difference ourselves. In the calculator, it will do that difference for us. So let me write that down. For the calculator, all we do, again, is second vars, go to normal CDF. It's always, again, normal CDF. And now we would do 110 to 120 with an average of 100 and a standard deviation of 15. So again, that's the lower bound, upper bound, mu, and sigma. And that will give us 0.1618, whatever it was, ... So again, these answers look different if you're typing them in on the homework and it tells you to use the calculator, but you use the tables instead, you're going to get the answer wrong. On an exam, I won't care, but on the homework, make sure you listen. When it says use a table, use the table. When it says use a calculator, either use Excel or use the calculator to get all the digits of accuracy correct. Okay, one last thing I want to talk about in relation to these problems. So we've done two problems, one where we did what's the probability that x is greater than some certain value. Here's what's the probability that x is between two values. But what if it's a totally different type of question? So let me add a third follow-up question to this. What if instead it wants to know sort of a percentile, or what percentage of people have a certain IQ score? So what is the IQ cutoff to put someone in the top 5%, which is, again, in essence, the 95th percentile? of IQ scores. Okay, so we framed the question differently. In these previous ones, I was asking for a probability. I gave an IQ or 2 IQs, and I asked for a probability. Now I'm not giving you the IQ scores, I'm asking for IQ scores. So this should be a question with a question mark. I'm asking for an IQ score. And this means that we have to do the problem essentially in reverse. So if you think about the process that we did before, what we basically did is we went from an X value, we converted that to a Z-score, and then from the Z-score we used the table to get an area / probability. That was the procedure for the first 2 problems. What we're doing now is essentially the reverse. And again, if we did this on the calculator, we could skip the middleman here. If we did this on the calculator in Excel, we didn't even have to compute the Z-score. It would jump straight from the X value to the area or probability, as you saw right here, right? We never had to enter the Z-scores. But if we're doing it by hand, this is the approach we had to take. Go from the X value, the IQ score, to the corresponding Z-score, use that corresponding Z-score to figure out using the table what the area or probability is. In this case, we're going in the reverse direction. I'm giving an area or probability. In this case, the area is, I'm interested in being in the top 5%. I'm going to use that to figure out a corresponding Z-score, and then use that Z-score to get the corresponding X value. So it's the reverse or inverse direction of what we were doing before. So let's do this first and foremost using the table. So this is our first approach again, using the table. If we draw the picture, we've got our curve. Here's all the X scores, and I'm saying I want the top 5% of area. So let's say that looks close enough. That area is 5%, which means that this area over here is 0.95, 95% of the area, right? So 5% can be written as a decimal as 0.05. And I want to know, what is this IQ score? So what is the value of the random variable x sitting at this location that separates the bottom 95% from the top 5%? That's what we're trying to figure out. So if we use the table, what we're going to do is do this problem in reverse. I'm giving the area or probability. So again, when we look at the areas, the area to the left of the score that I'm interested in is 95%. So let's zoom back in here real quickly. Let me erase that ugly Z and do a slightly less ugly one. These are the values I want. If I can figure out the Z-score, I can then use that Z-score to convert it and find an IQ score. But this is the important number. This is the area. Oops, let's undo that. This is the area to the left. Once we've drawn the picture, even though it talked about the top 5%, that means that the remaining, the area to the left, is 95%, 0.95. Okay, so that's the area I'm interested in, is 0.95. So I'm going to come back up to my tables, and I'm going to try to find that area. Remember, the areas fall in the middle of the table, and the Z-scores are along the edge. So I shouldn't look up 0.95. I shouldn't be looking up this number and this number and saying that's the 0.95. This is the number I'm interested in. This is the area. So I want to go through this list of numbers, looking for the number as close as possible. I want to find number in that meat of the table as close to 0.95 as possible. So let's go through it. If I just randomly start right here, right, we're at 0.93s. You'll notice these numbers are consistently getting larger as we move from left to right. Come down to the next one. We're getting closer, closer, closer. Oh, and I'm past it. I'm past 0.95. So somewhere back here, right here. these two values, whoa. These two values, come on, there it goes. These two values are the ones I'm looking for. One is a little bit smaller than 0.95, right? It's 0.9495, a little bit less than 0.95. And then this one's a little bit bigger, 0.9505. In general, you should always pick the number that's closer to the value of interest. But in this case, they're both the same distance, right? If you look at the difference between 0.95 and each of these numbers, this one is 0.9505, so it's 0.0005 larger than this number, whereas this one is 0.0005 less than this number. So these two are equally far apart. In that case, it doesn't really matter. You pick whichever one you want. But what is the corresponding z-score? Well, I will need to go back to, oh, come on. So it doesn't matter which. Let's just pick the 9505 for our case. Go back here, and it'll give me the z-score that I'm interested in. So either 1.64 if I pick the number on the left, or 1.65 if I pick the number on the right. And in general, this is one of the few cases where there is a tie. If instead I was interested in, the top 10% of cases, and so that would leave me wanting to find, instead of 0.95, the top 10% is separated from the bottom 90%. So I'd be trying to find the number as close as possible to 0.90. And it looks like that number would fall between these two values. Just again, so hypothetically different problem. If I was trying to find a 90%, which one of these two is closer to 0.9? Well, this one's off by 0.0015. This one's only off by 0.0003 less. So this would be the number I would pick. Oh, come on now. Let's just undo that. And I'll just point to it with the mouse. This is the number I would pick if I was looking for 0.9, because it's closer than this number. So we don't always just pick randomly. We are just picking randomly in this case because both of them, it was a tie. They were equally far from 0.95. But most of the time, if you're doing this in the table, one will be closer than the other, and pick whichever one is the closer one. So here's the two values, and they correspond to these two z-scores. So again, I find the number here, and I read out what is the corresponding z-scores. We're in row 1.6, and column either 0.04 or 0.05. And that's how I got the second decimal of accuracy here. 1.6 from being in this row, 0.04, 0.05 gave me the second two digits of accuracy. So that is the corresponding z-score that we're interested in. So if I come back over here, I'm going to call this, let's just pick the bigger one, 1.65. So now I have the z-score equals 1.65. We got this from, if I can write, from looking up an area of 0.95 in that table, in table A2. And it gave us this z-score. Now all I need to do, so I've done the part now where I've gone from the area to the z-score. Now I need to go from the z-score to the x value. And how do we do that? Well, we can use our formula. Again, our z-score is x minus mu over sigma, but that implies that if instead I want to know the x value given a z-score, so this gives me a z-score if you know the x value, that's what this formula does. If instead I want the x value for a known given z-score, like we've got here, I need to rearrange the formula. I need to solve it for x. And so I would solve it for x by multiplying both sides by sigma. I get sigma z equals x minus mu after I multiplied both sides of the equation by sigma. And then to get x by itself, I would have to add mu to both sides. So I'd get that x is equal to mu plus sigma z. And so for us, that x value, I already know mu for my problem. What is the average value mu for IQs? That's 100. What was the sigma score, the standard deviation? That was 15. And what is the z-score that we just found? 1.65. And that'll spit out the number x that I'm looking for. So again, let's just do that on the calculator real quickly. I want 100 plus 15 times 1.65. And it spits out the IQ that we need. It's about 124.75, or we could even just round it up to 125. It's close enough. So an IQ of 125 would put you right here on our graph. It put you right at the cutoff for being in the top 5%. And that is the answer to our question. So 124.75 or about 125. That's how we can do this on the table. How do we do this on the calculator and or Excel? So in the calculator, let me bring the calculator up. Let me only make that to go kind of halfway in there. Close all my emails. Okay, so on the calculator, how do we do this? So let me clear the whole thing. Again, it's going to be in the distribution. So I'm going to go to second vars to get to the distributions. And notice this problem I mentioned a minute ago, we're kind of doing things in the inverse direction. And that should be some indication to you that we are going to be using this third option, inverse norm. So that is the option I'm going to select. We're doing the normal problem, but in the reverse order. It'll ask for the area that we're interested in. That needs to be the area to the left. So that's where I'll put 0.95. And then it'll ask for the mean and standard deviation. And so for IQ scores, that mean is 100 and the standard deviation is 15. And if I now hit enter and hit enter again, it'll give me the 124 point, in this case, 6728. Something very close to this number that we found here, but even more accurate because we didn't have to round any values. We didn't have to round the 1.65. So on the calculator, second vars will get you to that list of distributions. Then we select INV norm, and it'll ask for three numbers: the area, 0.95, the value of mu, which was 100, and the standard deviation, which was 15. So the area, always to the left, then the value of mu, and then the value of sigma. And if you, again, have an old calculator that doesn't take you to the menu, you just type it in like you see it here. Just type in the inverse norm, so select that inverse norm function. It'll have a cursor waiting for you to enter information. Enter the information in this order: the area, the mean, the standard deviation. And that spit out for us, just write down the number that it gave us. Come on. That gave us about 124.67. Good enough. So it's very easy to do on the calculator, but again, I'd still recommend getting practice doing these with the table, because it'll just give you some more intuition for kind of how to manipulate things. What about doing the same problem in Excel or in a spreadsheet? Let me bring that up. So here is Excel or a spreadsheet. If I wanted to do the same problem here in Excel, let me put this so I can type again. I'm going to do it down here in this blank one. I'm going to start off with equals, and I believe if I start typing normal again, you'll see that one of the options here is norm.inv, or just norm_inv. So norm.inv is going to be the normal inverse, exactly like we're talking about. And it'll ask for the probability, the mean, and the standard deviation. So basically the same three numbers. So I will enter 0.95. That is the area or probability. It'll ask for the mean, which is 100, and the standard deviation, which was 15. And if I hit enter, boom, it will give me the exact same number that the calculator did, 124.6728. So in Excel, the function that we use is equal norm_inv. And you can use the period or not. Norm.inv, and it'll ask for, again, 0.95, 115. It asks for, and it'll prompt you. It calls it the probability, but again, we've already said the probability and area are the same thing. Area is probability, so it's the same thing. Then it'll ask for mu, and it'll ask for sigma, and it will spit out the exact same value, 124.67. So now you can see how to do this type of sort of reverse or inverse problem on both the table, calculator, and Excel. So hopefully this gives you a good rundown. Again, you'll get practice using the table because some of the problems on the homework will require you to use the table. And you'll also get some practice using either Excel or the calculator, your pick, because some of the problems on the homework will specifically ask for you to use the calculator. But again, if it asks for the calculator, using Excel will give you the exact same answer. So you're welcome to practice by using Excel instead if you plan on using Excel during the exams. So hopefully this gives you some sense of how to deal with kind of these applications problems. These are what they'll look like. And just let me know if you have any questions.